Hi guys, for this video lesson, we're going to discuss logical operators under your general mathematics from quarter 2, module 15. I'm your subject teacher, Arvin Enriquez. Our lesson objectives: at the end of this video lesson, you are expected to first define the logical operators: negation, conjunction, disjunction, conditional, and biconditional. Second, identify the logical operator used in a proposition. And last, perform different types of operations on propositions. Moving forward with our logical operators here, so just like with integers, fractions, rational expressions, polynomials, exponential functions, and the many other types of functions, there are operations involved in propositions. That is what this module is all about. So when we say logical operators, mainly we can say that these are connectives. So on a mathematical statements is a word or a combination of words that combines one or more mathematical statements to make a new mathematical statements. So that's how we use your logical operator or connector. Now, maybe a compound statement, no, is a statement that contains one or more operators. So that's how we deal with your logical operators here in the field of mathematics. So because some operators are used, no, we simply use these operators so frequently, mainly in logic and mathematics. So we give them names and use special symbols to represent them. So meaning to say there is a corresponding symbols for each of the logical operators. Just like, for example, conjunction, disjunction, negation, conditional, and biconditional. There is a corresponding symbol in each of, of these logical operators to represent this conjunction, disjunction, negation, conditional, and biconditional. Now, with the knowledge on propositions, you are now ready to understand the logical operators. Yes, it is no. We simply use these logical operators for us to combine two or more propositions that can be a compound proposition from a simple proposition. If we combine two simple propositions using your logical operators, the resulting proposition will be your compound proposition. So we can use their symbols and the corresponding verbal equivalence. So we can translate a compound propositions to a symbol using the symbols that represents these logical operators, or vice versa from the verbal or from the statement in words, we can convert this one to a symbols, or from symbols to words. Ultimately, you will learn how to perform the operations on propositions. Enjoy performing operations on non-numerical symbols. So, I mean to say, when we say non-numerical symbols, we are now dealing with symbols, no, not aligned to numbers. So, meaning to say, we are now uh, translating a given proposition to a symbol, or from a symbol, we are now translating these symbols to a proposition in words. So, entirely, this module is all about your logical operators dealing with your propositions. Now let's deal with the activity what's in. So our task now is to identify the connector or connectors used in each sentence. Write your answer in a separate sheet of paper. Here there are 10 sentences being given to us, and whereas now to identify the connector or connectors used in each sentences, because we can use two or more connectors, no, in each of the sentences being given to us. Now, for number one, it is not true that a good deed will give a bad result. So, what will be the connectors or what will be the logical operators used on this sentence number one? So here, as you can see, there is a not here. So that will be your logical connector here. And for number two, a happy heart is a medicine, and a sorrowful spirit weakens the bones. So there is an N here, a short connector. Next thing, for sentence number three, apartheid is only a thing of the past if and only if dark-colored people are treated the same way as with fair-colored race. So there is a if and only if here that will serve as your logical connectors. So it gives you a conditional, no? For number four or sentence number four, every person sides with God or one willingly chooses evil. So there is an or here that will serve as a logical connector. And for number five, or sentence number five, if bullying introduces a not so good background of the bully, then a psychosocial intervention should be designed for these bullies. So there's an if then here, as you can see, there's an if then here as your logical connector that being used, no, in your sentence number 5. And for sentence number 6, one can serve a master at a time, yet nobody can serve two masters simultaneously. So there is a yet here that will serve as your connectors here, no? And for number 7 or sentence number 7, working hard pays off and the satisfaction it gives is priceless. So there's a logical connector here which is your N. And for number 8, it is good deed to love friends, but it is divine to love enemies. So there is a but here. So we simply sometimes we use but as a replacement, no? And most of the time, no, we use but as a replacement of your N that will serve or that will represent your conjunction. Now, for sentence number 9, a wise person cherishes advices and a fool despises corrections. So there's an end here as a logical connector. Now, for number 10 or sentence number 10, if sharing inspirational stories relaxes a tired spirit, then keep telling such. So there's an if then here that will serve as your logical connector. So these are the most commonly used logical connectors dealing with your logic and your propositions. Now let's deal with this one. So it is what's new. So we're asked to copy the activity below in your notebook. Complete the paragraph by replacing the underlined letter with the appropriate logical connector that you will choose below. So then write the letter in the space provided above the blank of the logical connector that you have chosen. So as you can see here, so there is an activity. So we're asked to complete the paragraph. So by simply putting the right logical or the right and the appropriate logical connector in each of the blank. So let's start. So, hey, dear student, I know either you are enrolled in a private school. So where we can put this A. So we can put this A here, or, so let's read again. Either you are enrolled in a private school, you are studying, or you are studying in a public school. So it is correct. I bet it does blank matter. So from these logical connectors here, where we can put your U. So we can put your U here. So we can read again. So I bet it does not matter. So it is appropriate for that portion, no, that we put not as the missing word for that blank. So if you are in a private school blank, you should make the most of the available resources you have. So where we can put this E, so we can put this E here in your then. So there's a if and then scenario on this one. If you are in a private school, then you should make the most of the available resources you have. So there is a conditional proposition here. So in like manner, blank, you are in a public school, then you should value the big benefit of enjoying access to quality education for free. So what will be the right logical connectors that we can use on this blank? So we can put this one here, your T, to your if. So we can read again. In like manner, if you are in a public school, then you should value the big benefit of enjoying access to quality education for free. So it is appropriate to put if then, because that's an if then scenario. Now, for the next sentence, so victory knows no place. Blank, any individual can be successful. So where we can put your Y here? So we can put your Y here in your if and only if. So we can read again. So victory knows no place. If and only if any individual can be successful. So it is appropriate to put if and only if there. So for the last and next sentence, a person has to look at the brighter side B. One can grow wherever he or she is planted. So where we can put this B? So we can put this B here, no? So a person has to look at the brighter side, and one can grow wherever he or she is planted. Truly a God is spare. So we can provide now a word which is beauty. So putting a right logical connectors, no, it is a good idea to know how we put the right and appropriate logical connectors in combining a propositions, a sentences, a statements here in this activity. Now, did the message sink in? I hope so. So mind you, that will you do good, dear learner? Now you are very ready to learn a new lesson, which is all about your logical operators, and that pertains to your conjunction, disjunction, negation, conditional, and biconditional. Let's deal now to what is it. So logical operators enumerated. So let us consider logical connectors we joined with propositions. So in this part, we shall deal with logical operators. So here are the logical operators that we're going to use. So logical operators include first your negation, second your conjunction, third your disjunction, fourth your conditional, and lastly your biconditional. Now, in the discussion below, as you can see in this negation up to your biconditional, each of the logical operators will be defined with the aid of a truth table and truth values. Although this will be discussed in depth in the next module. Yes, it is, no? We just simply use truth table here for us to represent or for us to define what is a negation, disjunction, I mean conditional and biconditional. But on the next module, we're going to discuss more about this negation, conjunction, disjunction, conditional, and biconditional. Now, we define your negation here. So your negation of a proposition P is denoted by, so we use this symbol, I mean, to represent your negation, which is read as not P, and is defined through its truth table. As you can see in this one, the truth value of your original proposition is true and false. Now, going to your negation of this proposition P, or the not P, no? We what is whatever, no? The total opposite of your original proposition P, that will be the value of your negation of the proposition P or the not P. So in your original if your original proposition, or if the truth value, no, of your original proposition P is true, then your negation of a proposition P is now false. So meaning to say, whatever, or your negation of proposition P is the total opposite. No, I mean the truth value of the negation of a proposition P is totally opposite of the truth value of your original proposition P. Now, in this case, using your truth table here, in your first column, that will be the value of your original proposition. Now, as you can see, whatever your truth value or values in your second column for the negation of that proposition P is totally opposite of what truth values indicated in your first column for your original proposition P. As you can see, if in your propositional P, the truth value is true, then for your negation propositional proposition P now is false. If the truth value of your original proposition P is false, then going to your negation of a proposition P, the truth value of this one is true. So I mean to say, totally opposite of what the truth value or values for your original proposition. So that's how we define your negation. Simply, it is that opposite, no, truth value or values of your original proposition. Again, if your truth value for your original proposition is true, and when you're asked to find the negation of that proposition, then the negation of the truth value of that negation of that proposition is now equal to false. Simply totally uh, opposite, no, of what your truth value in your original proposition. So that's how we define your negation of your proposition P here. So for example number 1, so we're asked to state the negation of each of the following propositions. So we're asked to convert the original proposition to their negation, no? For your proposition under your N sub 1, quality determines the price. So what will be the negation of this one? So we can use it is not here, no? It is not true that quality determines the price. We can put it is not true, and this will serve as your original proposition. By simply putting it is not true, it will represent your negation. These words, no, that it is not true, represent your negation. Or we can rewrite this original proposition by another term. Again, no, in converting this one to negation of that proposition, it can be quality does not determine the price. So by simply using does not here, mean to say you are opposing this one, totally opposite of your original proposition. That's why we define your negation as the opposite of your original proposition. If the truth value of your original proposition is true, and the truth value now of your of that proposition is now false, because negation is totally opposite of what the truth value of your original proposition. And for number 2 here, or the N sub 2 proposition, a learned is one who is educated, I mean. Now in this case, no, we just simply put not here. A learned is not one who is educated. As you can see here, we just simply use not for us to convert the original proposition of N sub 2 to its negation of that particular proposition. Now, for your N sub 3 proposition, f of x is equal to x squared is a cubic function. Now, how can we convert this one? So we can convert this one as f of x is equal to x sub 2 is not a cubic function. So we just simply put not here, no, for us to oppose the original proposition under your N sub 3, and for us to convert this original proposition to its negation. Or we can rewrite this one, or by simply putting it is not true that f of x is equal to x squared is a cubic function. So we just simply put here it is not true. So it's the same meaning. So our main goal now is to oppose your original proposition. Or by simply using not, it is not. So still the same, no? So whatever between not and it's not true, we can use these two logical operators that will represent your negation. Now, for n sub 4, for your proposition, for your n sub 4 here, an obtuse angle measures 180 degrees. So we're asked to translate, or we're asked to convert, I mean, no, this one to its negation. So an obtuse angle does not measure 180 degrees. So we put does not here for us to oppose, no, the original proposition. And for n, or in another way, no, on how we convert this one to its negation, an obtuse angle measures greater than 180. So even if we uh, don't put no a not or it's not true, so still we can convert this original proposition to a negation by simply just assessing no or by simply uh, converting no the meaning of the original proposition to another statement that can bring you a meaning which is opposing the original proposition. Here, as you can see, if you read this one, an obtuse angle measures 180 degrees, meaning to say exactly, no? Your obtuse angle measures 180 degrees. So there is no such thing as 170, 190. So if our statement, no, will be aligned to more than 180 or less than 180, then we are just simply opposing the statement that an obtuse angle measures 180 degrees without putting does not, or it is not true. Our main goal in your negation is just to oppose no your original proposition. So here, as you can see, an obtuse angle measures greater than 180. So we are opposing your original proposition there because your original proposition says that your obtuse angle measure exactly 180 degrees. And for your P proposition here, a curve is the shortest distance between 2 points. How can we convert this one to its negation? So the negation of the proposition n sub 5, so a curve is not the shortest distance between 2 points. So we put not here for us to convert no, this original proposition for n sub 5 to its negation. So that's how we deal with your negation. Again, your negation is totally opposite of your original proposition. By simply putting it is not, does not, to represent your negation, or by simply or allowing yourself to change the meaning of the original proposition by simply opposing the meaning of that original proposition without putting does not, it's not true, then we are just dealing with your negation. As long that we oppose or totally opposite of your original proposition, uh, that your new meaning that pertains to. Let's now go with your conjunction. Your conjunction defined another logical operator is conjunction of the propositions P and Q, which is denoted by your P, and we use this symbol to represent your conjunction and read as P and Q. So this symbol will represent your conjunction, or we can read this one as P and Q, and it's defined through its truth table. So as you can see in your truth table, there are 3 columns. So in your first column, this will be the truth values for your P proposition. And for the next column or the second column, that will be your truth values for your Q proposition. Now, for that last column here, for the third column, that will be your truth values for your P and Q, or the conjunction of the propositions P and Q. Now, how can we deal with this one? So if there are 2 propositions being given to us, that will be your P and Q, and they have their truth values. So what will be the resulting truth values if we combine these 2 propositions P and Q using the logical connectors, which is your conjunction? Now, as you can see in the second row here, the truth value of your proposition P is true. Same thing with the truth value of the proposition Q. Now, what will be the resulting truth value if we are using conjunction? Again, if both your proposition P and Q, or both the truth values for your proposition P and Q are true, then the truth value of the conjunction of the propositions P and Q, or the truth value of P and Q now, is equal to true. I mean, because the conjunction P and Q is true only when both conjuncts P and Q are true. Meaning to say, if the truth value of the proposition P and Q are both true, then if we're asked to look for the truth value of the conjunction of the propositions P and Q, it is automatic that the truth value for this P and Q now is equal to true if both truth values for P and Q are true. Now, if one of the truth values between your two propositions P and Q is false, then the resulting value for the conjunction of the propositions P and Q now, or the truth value for your P and Q, is now false. As you can see in this one, for the third and fourth row, one of the truth value for your P and Q propositions is false. So I mean to say, at least one of your truth value for your two proposition is false. It's automatic that the conjunction of the proposition of P and Q, or the conjunction of P and Q, is automatic false, or the resulting truth value now is false, even if one of the truth value for these two propositions is true. At least one of them, truth value is false. It's automatic that the resulting value, as we use your conjunction as your logical operator, the truth value now, or the resulting truth value now, is false. It's the same thing for your fourth row here, which is the truth value of your P proposition is false, and your truth value for your Q proposition here is true. Meaning, say, one of your truth value between your P and Q proposition is false, then it's automatic that your resulting value for your truth value for your conjunction of the propositions P and Q now, or the truth value for your P and Q, is automatically false. It's the same thing, when your two truth values for your P and Q propositions are false. So the resulting truth value here is automatic false. When the two truth value of from these two propositions are false, then the resulting truth value for the conjunction of these two propositions is automatically false. So as you can see on the table. Now, in a simple word, if both the truth value are true, it's automatic dealing with your conjunction. The resulting truth value now is true. As long that you see a false truth value, it can be one of them or both of them, it's automatic that the conjunction of this proposition or propositions are false. So that's how we deal with your conjunction. That's why your proposition P and Q are called conjuncts. So they are called conjuncts. Now, the conjunction of P and Q, or P and Q, is true only when both conjuncts P and Q are true. If and only if your P and Q are true, then the resulting truth value for your conjunction of the propositions of these two, P and Q, are true. So that's how we deal with your conjunction as your logical operator. For example number 2, let D and E be propositions. So we simply use two propositions here, your proposition D and your proposition E. So for your proposition D, leniency is long-suffering. So that will be your proposition for your D. Now for E, those who misunderstand it abuse it. So that will be your proposition for letter E. Now, express the conjunctions below in verbal sentences or in symbols. So whereas now, to combine these two propositions using the logical connector conjunction for us to provide a new truth value for this proposition D and E. Now, for number 1, so what will be the truth value, or if we're asked to convert this to, since the given is in symbols, we're asked now to convert this one to, or express this one in verbal sentences, or in verbal, or in words, I mean, no, since the given is in symbols. Your D, or the conjunction of your proposition P, D, and E. So how can we express this one in words? As you can see, what will be your proposition D? So leniency is a long suffering. So that will be your proposition D here. And what will be your proposition E? So your proposition E here, those who understand it abuse it. So this will be your E proposition. So what will be your conjunction? We use N, no, to represent your conjunction. So this will be the symbols. That's why we read this one as D and E. Because if we convert this one to in words, no, or in verbal sentence, no, these symbols, then we simply use N for us to combine these two propositions and for us to provide a conjunctions of these propositions. And for number 2, as you can see, there is an involvement of two propositions. I mean logical connectors, no? That will be your negation and your conjunction. As you can see here, leniency is not a long suffering. So we use not here for us to represent the negation. That's why there is a symbol here. As you can see, there is a symbol here as negation that will represent your not here. So leniency is not long suffering. So this will be your negation D. Then next is that there is no negation in your proposition E. That's why we copy your proposition E. So this will be your E. And this will be your conjunction. That's why if we're asked to convert these symbols to in verbal or in words, then we just simply assess first what will be the logical connectors that is being used for us. That's why we put negation not here to represent the negation, because there's an involvement of negation, because we can use two or more logical connectors in one statement. That's why we just need to know how to use these logical connectors appropriately and inputting those logical connectors. Now for number 3, now in this case we're now asked to express this one to in symbols because the given is in words or in verbal sentence. Now leniency is a long suffering, and it is not true that those who understand it abuse it. As you can see, so this will be your D from this case, This will be your D, and this will be your conjunction that represent and that will represent your conjunction. And as you can see, inside your parenthesis here, there is a negation E. That's why we use it is not true to represent this negation or to oppose the original proposition E, no? So whatever the meaning, again, we define your negation as the total opposite of your proposition E. That's why we put it is not true to oppose the original meaning of that proposition E, because there's a negation sign inside your parenthesis for number 3. So that's how we deal your negation here for your conditional. Now, for number 4, leniency is not long suffering, and those who understand it do not abuse it. As you can see, there is a not for both of your propositions. So we apply your negation in both your proposition D and E. So there is a negation D here and negation E. As you can see, inside the parentheses, there is a negation E there. And we use conjunction here. Now, leniency is not long suffering. So we use not to represent the negation for your negation D. And we use it is do not here, no? Do not abuse. So we use do not to represent your negation for your proposition E. So that's how we deal with your conjunction plus the concept of your negation. So here, there's an involvement of your two logical operators, and that will be your negation and the concept of your conjunction. So for example number 3, let R, S, and T be propositions. So here, as you can see, there are 3 propositions involved in this example number 3, your proposition R, your S, and your T. For your proposition R, this will be the statement: there is a profit in physical exercise. For proposition S, it is best to exercise holiness. For proposition T, a person must be holistically fit. Now, for us to express the conjunctions below in verbal sentences or in symbols. For number 1, there is a profit in physical exercise. So this will serve as your R here, as you can see. This will serve as your R in your answer. So this will serve as your R proposition, as you can see in the given proposition. And it is best to exercise holiness. So it is best to exercise holiness represent your proposition S here. And N, that will represent your conjunction. So as you can see on these symbols R and S, R, we just simply copy the original proposition R, then we apply the logical connector N to represent the conjunction between your two propositions. And S, there is no involvement of negations there. That's why we just simply copy the original proposition S, and it is best to exercise holiness. Now, for number 2, as you can see on the answer, so there's a negation here of R, conjunction T. So there is no profit in physical exercise. As you can see, the original proposition R is there. The proposition or the statement claims that there is a profit in physical exercise. But once we apply your negation, we are just simply opposing, whatever the meaning of the original or the given proposition by simply putting no here, meaning say there is no profit in physical exercise. So this portion represent the negation R, because we put no, or we just simply opposing whatever the original proposition R is, that there is a claim that there is a profit in physical education, physical exercise. I mean, once we put no there as your logical operator, then the meaning will change, and totally opposite on the claims for your proposition are there. That's why it is a negation R. Now, as you can see here, a person must be holistically fit. So it is from the proposition T. So we just simply copy the proposition T. Then there's an N here that will represent your conjunction. That's why, as you can see here, your negation R, conjunction T, as you can see, we use N to represent your conjunction. Then we apply no, or we just simply put no to oppose the original meaning of your R. And we just simply copy the original proposition under your T. No? As you can see, that's why how we convert these given sentences or statements, no, in symbols. Now, for number 3, so there's a given symbols here, no, that are conjunction negation T. As you can see, there is a profit in physical exercise. As you can see, this will serve as your original, no, original proposition R. So from this one, no, from this one, we just simply copy the original proposition R. There is a profit in physical exercise. Conjunction. So this will be your conjunction. It is not true that a person must be holistically fit. So this portion is from your proposition T. But this portion represent your it is not true, no? It represents your negation. Meaning to say that our conjunction negation T here, so we just simply put it is not true before your proposition T to make it, or to provide for us to provide, no, a new meaning or totally opposite of the meaning of the original proposition T, because there is an involvement of negation. And for number 4, as you can see here, there is a negation on R. So this will be your R here. There is a profit in physical education. So we need to put no here to make this one as negation of R. Totally opposite of the original proposition R. And that will represent your conjunction, and it's best to exercise holiness. That will represent your original proposition S. That's why if we're asked to convert this negation R, conjunction S, we just simply copy your proposition S, then apply the negation to your R, then we put logical connector, which is N, that will represent your conjunction between your negation R and your original proposition S. Again, that's how we deal with your negation and conjunction. We just simply use N to represent your conjunction, and by simply putting no, does not, it is not true, then we just simply representing your negation. Moving forward with your disjunction, so it defined, no? Your negation and conjunction do not suffice logic. There are logical statements that connote the disjunction of propositions. So the disjunction of propositions P and Q is denoted by, so we simply use this symbol to represent your disjunction, which read as P or Q, and defined through its truth table. As you can see here, the truth table, no? So once we apply your disjunction, as you can see here, no? If both your truth value for your original proposition P and Q are true, then the disjunction or the truth value for the disjunction of propositions P and Q is also true. As you can see in this one, no? In your first column, this will be the truth value for your P proposition. Your second column will represent the truth values for your Q proposition. And for the third column, this will represent the truth value for your disjunction of propositions P and Q. As you can see on the second row, this will serve as the first truth values for P, Q, and your P or Q. Now, if both propositions have the same truth value, which is true, I mean, then automatic that the truth value of this disjunction of propositions P and Q is also true. As you can see, your P proposition here is true, your Q proposition is true, and it's automatic that disjunction of proposition P and Q is true. Now, in this case, no, if one of your proposition from your third and fourth row here, there are scenarios wherein one of the truth value between your two propositions P and Q is true, as long that there is one truth value between the truth values of your P and Q propositions is true, then the disjunction of propositions P and Q is also equal to true. Unlike in your conjunction, if one of the truth value between the truth values of your P and Q proposition is false, automatic that the conjunction of propositions P and Q is false. But in your disjunction, if one of your proposition is true, even if the other one is false, then the disjunction of the propositions P and Q now is automatic, or the truth value of the disjunction of propositions P and Q is automatic true. As you can see from this row number 3 and 4, your P proposition is true, your Q proposition is false, and the disjunction propositions P and Q now is true. Now, in your fourth row, it's the same thing. One of your proposition is false and one is true. And it's automatic that the disjunction of propositions P and Q is true. But in the last part of this truth table for this disjunction, if two truth values for your propositions P and Q are false, then it's automatic that the truth value for disjunction of proposition and P and Q is now false. As you can see, if this P proposition is false, then your Q proposition is false. It's automatic that the disjunction of propositions P and Q now is also false. So that's how we define your disjunction. Now, your propositions P and Q are each called disjuncts. So please do take note of that they are called disjuncts. The disjunction P or P or Q is false only when both disjuncts P and Q are false. If both truth value of the P and Q propositions are false, then the truth value of your disjunction of proposition P and Q now is also false. But if one of them are true, then the resulting truth value is true. If both of them are true statements, then the truth value again now is automatic true. So that's how we deal with your disjunction by simply using your truth table here. We just simply see the difference between your conjunction and disjunction. Now let's deal with this example number 4. So let T, U, and Y be propositions. Here there are 3 given propositions, your T, U, and Y. For your T, your proposition T, He is an old soul. For proposition U, all songs suit his ears. For your proposition Y, old passion is inviting to his eyes. So express the disjunctions below in verbal sentences or in symbols. So we're asked to convert, or we are asked to express, no, the disjunctions below in verbal sentences or in symbols. Now, in this case, we're going to apply the three logical operators, your negation, conjunction, and biconditional. For the first one, let's express this one in words since the given is in symbols. For number one, your U and your Y. So there's an involvement of your proposition U and Y. As you can see, we just simply copy your proposition U. As you can see in this answer, we just simply copy your proposition U here. All songs suit his ears. So that will be your proposition U. Then again, there's no involvement of conjunction, disjunction. I mean, there's no involvement of negation and conjunction. Only we apply your disjunction. And for your Y, it's a original proposition. That's why we just simply copy, no, the original proposition Y, which is all passion is inviting to his eyes. This will be your Y now. Then your or here will represent your disjunction. We simply use or to represent your disjunction. Again, we just simply use, no? We just simply use or to represent your disjunction. Now, for the second example here, no? Your negation, conjunction, negation U, disjunction Y. So let's first deal with the proposition and the logical operators inside the parentheses. Now, here as you can see, either he is not an old, since there's a negation T here, we apply the negation. Either he is not an old soul, so this will be your negation T. As you can see, this will be your negation T. So this part is your negation T because we apply your not here as to represent your negation. And all songs do not suit his ears. So this one will represent your negation U because we simply use do not suit here to represent your negation there. And here will represent your conjunction. Your N there, between the negation of T and U, the N there is to represent your conjunction. That's why we use N. Now, in this case, after applying, no, if we put a parenthesis, this will be the term for your parenthesis. Either he is not an old soul and all songs do not suit his ears. These resulting as propositions now represent the term, no, or terms inside the parenthesis here. Now, we apply your disjunction. That's why we use or here. We use your disjunction or. Then your Y, we just simply copy the original proposition Y. All passion is inviting to his eyes. That's why we use Y here. So that's how we convert symbols to in words or verbal sentences. Now, for number 3, there's a given here. How can we convert this one into symbols? Either he is an old soul or old songs suit his ears and old passion is inviting to his eyes. As you can see in this one, he is an old soul. So we just simply copy your original proposition here, which is your T. This will be your T. Your or will represent your disjunction. That's why we use old or here. All songs. So inside your parentheses, so we just simply, first for us to see, no, we just simply put parentheses here for us to visualize more. What will be the term that is best suitable or that is appropriate to represent the symbol, no, inside your parentheses? So in this case, how can we convert this in words, no, to symbols? All songs suit his ears. What will be, no? What will be the proposition for this one? So that will be your U. Then there's a logical connectors here, N. So this will be your conjunction. And old passion is inviting to his eyes. That's why it is your Y there. So your original proposition Y. We just simply copy your original proposition Y there. So as you can see, no, there is a order for us to follow, no? So parentheses in symbolic statement, we can say that parentheses in symbolic statements are used to tell what type of statements are being considered. So you must take note of this. If there are no parentheses, we follow the dominance of connectives. So there's a dominance, no, in connectives. The list below, or the list that I am going to provide for you guys now, is in their dominant order from the strongest to the weakest. So the strongest, if there's no parenthesis being involved, the strongest logical connectives is your biconditional. Second is your conditional. Third is your disjunction and conjunction. Your conjunction is and disjunction are on the same level of dominant, no, dominance, no. That's why for the last or the weakest, no, connectives, that will be your negation. That's why if there is no parenthesis, if for us to convert a symbol, no, to in words or in a verbal sentences, and there's no parenthesis being given, we just simply follow the dominant order of these connectives from strongest to weakest. Again, the strongest is the biconditional, 2 is the conditional, and for the third spot, that will be disjunction and conjunction. They are on the same level, and for the weakest logical connectives, that will be your negation. Again, your conjunction and disjunction are of equal value. So you need to take note of that. Please do take note of that. And for number 3, as you can see, that's how we convert for this one. Now, for number 4, this will be the answer. Oh, so how we come up with this one. So as you can see here, there is a, he is not an old soul. As you can see here, he is not an old soul. From what proposition? That will be your proposition T. So that will be the negation of proposition T. N, we simply use N to represent your conjunction. So we just simply put parentheses here first, no? Either old passion is not inviting. Is not inviting. So we use not for your proposition Y. So that will represent your negation Y here. Or we use or here. That's why there is a disjunction. Disjunction or old songs suit his ears. Meaning to say we just simply copy your proposition U, and that's it. No? We apply your logical operators for us to combine 2 or more propositions in a way that we can translate or express both, no, in symbols, in verbal sentences, or in words. So that's how we deal with your disjunction. Now let's deal with your example number 5. Let J, K, and L, M, N be propositions. So your J, for your proposition J, laughter is the best medicine. Your K, grief causes illness. And for L, prayer relieves pain. And for M, proposition M, God takes charge of worries. Here there are four propositions being involved for this example number 5. And let's see if we can use these four propositions by simply using logical connectors if we can combine these four propositions here. Now, express the disjunctions below in verbal sentences or in symbols. Now, for number 1, as you can see, for number 1, so here, as you can see, we follow the dominant order. For number 1, it is either God takes charge of worries. So that will be your M. N, and there is a conjunction here. So this will serve as the representation of your proposition M. So there's a conjunction N there. Laughter is the best medicine. So that will be your J. As you can see, there is a J there. So first, for us to visualize more, no, we just simply put a parenthesis here for us to see how we can represent this one in symbols. So that will be M conjunction J. Because there's an N, we copy both your original proposition for your M and J. Or this will serve as your disjunction here. Prayer relieves pain. So there is no such thing as application of negation for your L. That's why we copy again your original proposition L. That's why our answer is M conjunction J. So whatever the resulting value between your M and J for your conjunct, they are conjuncts. Now, the resulting value for that conjunction will be combined to L using disjunction. That's why it is now M conjunction J disjunction L. Now, in this case, no, for number 2, we just simply follow the dominant order since there is no parenthesis being involved. In this case, no? In this case, laughter is not the best medicine. So we use not and we apply not to proposition J. That's why this part is your negation J. Now, we use N to represent your conjunction. God takes charge of worries. So this will represent your M, proposition M, or this will represent your disjunction. Prayer relieves pain. So this part will represent your L. As you can see, there's only an application of negation in the proposition J, which we can apply, which we applied, no, the word not, no, laughter is not the best medicine. As you can see, that's how we can express this verbal sentence here in symbols. Now for number 3 here, how can we express this one to in words? No, your J disjunction L. So your J, laughter is the best medicine. So this will be your J. Your or is your conjunction. Disjunction, or. This will be your J. Then, prayer relieves pain. So we just simply copy your L there. So this will be your proposition under your L. Because in your given J disjunction L, there is no involvement of negation and conjunction. That's why we just simply copy the original proposition for J and L. Then we apply the disjunction. That's how simple it is, no? And for number 4, as you can see here, there is a parenthesis, no? it is either, so we put here before and after or, a parenthesis, no? For first one, it is either laughter is the best medicine. So this will be your J. And this one will serve as your conjunction N, because there is a conjunction N here. And griefs causes illness. So griefs causes illness will serve as your K here. Then this or will represent your disjunction. Prayer relieves pain, and that will be your original proposition by L. And there is an N again for your conjunction. God takes charge of worries. So that will be your original proposition M. So that's how we convert your or how we combine, no, two or more propositions using your logical operators, and we express this one in verbal sentences, in words, or in symbols. Now for number 5, we apply negation to K, we apply negation to J, we apply conjunction between your negation K and negation J. Then after that, whatever the resulting value, we disjunct this one to the resulting value for LMN, or L, that will be your proposition 1, this conjunction M. So there is no negation here. Now let's see it. So we put a parenthesis for you to visualize more what it is, no? So either griefs does not. So we use does not here to represent your K here, no? The negation of this one does not. And N will represent your conjunction here. Then is not the best medicine. So we just simply opposing your J. That's why your J here will be this one. Or this will be your disjunction. And then for LMM, for propositions, there's no negation. We just simply copy the original proposition and apply in between them the N word for the conjunction. Prayer relieves pain, so this will be your L. This will be your conjunction. God takes charge of worries, so this will be your M. So that's how we deal again, no, on how we use disjunction as your logical connectors for this example number 5. Let's deal now with your conditional defined. Another common kind of logical propositions includes conditional. So the conditional of propositions P and Q is denoted by, so we use this symbol to represent your conditional, which is read as if P then Q, or P implies Q, and defined through its truth table here, as you can see in this one. So in your first column here, this will represent the truth value for your proposition P. And for the second column, the truth value for your proposition Q. And for the last column, or the third column, that will represent your truth value for your P implies Q, or the conditional of propositions P and Q. Now, in this case, as you can see here, no? As you can see, the proposition P is called the hypothesis. No? Please do take note of that. The proposition P is called a hypothesis, while proposition Q is called the conclusion. Now, in this case, for the second row, as you can see, if the truth value of the proposition P is true, and the truth value of the proposition Q is also true, then the conditional, or the truth value of the conditional of propositions P and Q is automatic true. So that's how we see it, no? If if both truth value of your P and Q propositions are true, then the resulting value for the truth value now is also equal to true. Now, but in this case, as you can see on this third row here, your P proposition is true, your Q proposition is false, but the resulting truth value for these conditional propositions P and Q is false. Meaning to say, whatever the truth value of your second proposition Q or your truth value of your conclusion, no? If one of your proposition is false between P and Q, we just simply, or one of them is true, or vice versa, no? If one of them is false, the resulting truth value for the conditional of proposition P and Q now will be dependent on the truth value of your conclusion, which is your second proposition Q. Now, in this truth table here, your second proposition is Q, and that will be your conclusion. If P is true, Q is false, automatic that the conditional of propositions P and Q is false, because the resulting truth value for this one, if we combine this one using the connector conditional, then the truth value of this one will be dependent on the truth value of the conclusion. If one of the truth value between the original proposition P and Q is true or false, no? That's why the truth value in the third column will be dependent to your conclusion. So whatever the truth value in your conclusion, as long that one of them is false or true, then we follow whatever the truth value in your second proposition, which is your true, which is your Q proposition, I mean. So it's the same thing with this fourth column here. Your proposition P is F or false, then your Q proposition is true. That's why the resulting truth value for your P conditional here is true. So that's how we deal with this one. We just simply follow the second truth value of your conclusion or proposition Q. If one of your truth value between your P and Q is true or false, or vice versa, no. Now, in your last row here, your F, if one of your proposition is false and another one is also false, then the resulting conditional of proposition P and Q here is now equal to true. So that's the only difference, no, between your conditional, your conjunction and disjunction. But in this case, no, in your disjunction and conjunction, we follow that the resulting value is false. But in this case, in your conditional, if both truth value of your P and Q propositions are false, then it's automatic that the conditional propositions P and Q is true, even if both truth values of your P and Q are false. So that's how we deal with this one. I hope you understand that, no? The difference between your conditional, disjunction, and conjunction. And with the use of this truth table, I hope that you will learn, no, how to differentiate these three logical connectors from one another. So for example number 6, so let X, Y, and Z be propositions. So X, for proposition X, dioxins are found almost everywhere. For proposition Y, plastics, bleach paper, and most commodities contain the chemical dioxin. And for proposition C, dioxins are culprits to many diseases. So that's how we deal with these X, Y, and Z propositions. Dioxins are culprits to many diseases. So that will be your X, Y, and Z propositions. Now, express the conditionals below in verbal sentences or in symbols, as the case may be. So in number 1, X implies Z, or the conditional uh, of propositions X and Z. So we just simply copy the proposition, no? It will represent the if then. No, we use if then here to represent, no? To represent the conditional, the if then. So we use if then here to represent your conditional, if then. So we just simply copy your dioxins are found almost everywhere. So that will be your proposition X. Then your if then will represent your conditional. They are culprits to many diseases. So this will be your C, as you can see, no? We just simply copy the original propositions from your X and Z, then we apply the if then. So we just simply replacing some of the parts because we just simply following the good and appropriate grammar for this one. That's why, no, we come up with this idea that we use if and then they are culprits to many diseases. They represent also your dioxins. Because if dioxins are found almost everywhere, then we cannot use dioxins. So it is appropriate to use they to represent dioxins for the second part of this sentence. Now for number 2, negation Y, conditional negation X, conjunction negation C. As you can see on this one, the negation, no? If plastics, bleach, paper, and most commodities do not contain the chemical dioxin, so that will be your negation Y. So this will represent your negation Y. Then it is not true that dioxins are found almost everywhere, and it is not true that dioxins are culprits to many diseases. So we use not here and not here. It is not true, no? To represent the negation for number 2 here, as you can see. And then we apply the if then for your conditional. Now for number 3, as you can see for number 3 in this case, if dioxins are culprits to many diseases, so that will be your Z. The if then will represent your conditional. They are found almost everywhere. What will be? So we apply your parenthesis for you to visualize more the symbols, no? They are found almost everywhere. That will be your X. Then here there's an N here that will represent your conjunction. Plastic, bleached paper, and most commodities contain the chemical. So these represent your Y. That's why we come up with these symbols here, as you can see. And for number 4, if dioxins are not found almost everywhere, that is the negation of X, as you can see. If dioxins are not found almost everywhere, not found, as you can see, there's a negation of X here. The if then we follow, so we apply the symbol. If then it is not true, so we apply again the negation. That's why there is a negation here between the disjunction of Y and Z. So after applying the disjunction between your E and Z, no, as you can see that either plastic, no, so there's an or here to represent your disjunction. That's why your negation X, conditional negation with the resulting value between the disjunction of y and z now as your proposition, then it is necessary, no, that we apply first the disjunction between your y and z, then we apply your negation. Then, going forward to apply your conditional as your logical connector. For example number 7, so let f, g, and h be propositions. So for your f proposition, parabens are harmful to the body. For your proposition G, parabens are found in many products we use. For proposition H, parabens can affect health. So we're now asked to express the conditionals below in verbal sentences or in symbols, as the case may be. As you can see, this one, your F conditional age. So we just simply copy your F conditional age. So if parabens are harmful to the body, so this will be your F. Then we apply your if then, as you can see, if then that will represent, no, your conditional symbol here. Your H, we copy, they can affect, that parabens can affect health. So they can affect health. So we apply your if then to represent your conditional. And we just simply copy your F and H propositions here because there is no negation, as you can see, being applied to number 1. And for number 2, so it's a combination of conjunction, negation, and conditional. First thing to do is to apply, no, or to get the resulting truth statement for the terms inside your parentheses for number 2. What will be that way? That parabens, no, parabens, negation, we apply your negation, are found in many products we use, and if they are not, negation again, not harmful to the body, so that will be the term or the phrase, no, inside your parentheses here. As you can see, this one, negation G, conjunction negation F. So this N will serve as the conjunction. The if then here will represent your conditional here. Then negation H, we just simply put not to your H there. Parabens cannot affect health. So we just simply opposing the meaning of your proposition 8 that parabens can affect health. So that's how we express this one in sentence or in words. For number 3, if parabens are harmful to the body, so that will be your F. So we just simply copy your F, no, proposition. Parabens are harmful to the body, and conjunction are found in many products we use. So that will be your G. Now applying your conditional, so we use this symbol because there is an if and then here. As you can see, if and then here. So we apply this symbol, then they can affect health from your proposition H. So there's no application of negation here. So we just simply put H here. That's why it becomes on this scenario, no, as your answer. Now, for number 4, if parabens cannot affect health, as you can see here, if parabens cannot affect health, so that will be your negation H, because people cannot. Or assure disjunction. So from this scenario, no, we put parentheses for you to know the phrase, no, for the term or terms inside your parentheses in this case. Or they are not found. So again, there's a negation in your proposition G. That's why we apply negation G. So we put parentheses. We apply your if then. then they are not harmful to the body. That will be the negation of F. That's why your answer here is equal to these symbols. Now let's deal with this one. So your biconditional defined. So the last logical proposition that we shall consider is biconditional. This is denoted by P, and we use the symbol to represent your biconditional Q, or P if and only if, no? If the if FF, no? Given propositions or components P and Q, and it is read as P if and only if Q, and defined through its truth table here. As you can see, again, for the first row, first column, that will be the truth value for your proposition Q. And for the second column here, this will be the truth value for your second proposition Q. And for the third column, that will be your truth values for the biconditional of proposition P and Q. And for the second row here, as you can see, if proposition P is true and second proposition Q is true, the biconditional or the resulting truth value for this biconditional is also true. Now, in this case, no, in this case for this third and fourth row, if one of your proposition is false, then it's automatic the biconditional of these two proposition is automatically false. As you can see, your P is true, your Q here is false, then the biconditional of this proposition is also false. Meaning to say, if one of them is false, it's automatic that the biconditional of these two proposition is automatic false. Now, it's the same thing with the fourth row here. Your P is false, your Q is true, then it's automatic that the biconditional of these two proposition is false because one of them is a false statement. Now, if both P and Q are false, then the biconditional between your two propositions P and Q is true. Meaning to say, no, if in this biconditional, if both propositions are true, then the biconditional of these propositions is also true. If both propositions are false, then the biconditional of this proposition is true. As long that your two propositions are true and false, no? Or false, I mean, if both of them are true and or both of them are false, then the resulting value for that biconditional of these two propositions is also true. No? That's how we see it. For example, number 8, let G, H, and I be proposition. For your proposition, so there's a J here, so there's a typographical error, so there's still a J proposition. For your G proposition here, only physical handicap individuals can be called person with disabilities. For proposition 8, psychosocially disabled person, like those with chronic illnesses, can also avail PWD ID. And for I, there are numerous benefits which come along with owning a PWID. And for J, knowledge of the wide extent of who a PWD has yet to be spread. So there are four propositions here that are involved, no? In this example number 8, and we're asked to express the biconditionals below in verbal sentences or in symbols. For number 1, negation Q biconditional H, conjunction J, conditional I. So first thing to do, we apply the not physically handicapped individuals. No, as you can see, not only we use not to represent the negation of G can be called person with disabilities if and only if this will represent now your biconditional psychosocially disabled person like those with chronic illness can also avail PWID, so that will be your age now. And this will be your conjunction. If knowledge on the wide extent who a PWD has yet to be spread, then the if then will represent your conditional. There are numerous benefits which come along with owning a PWID. Meaning to say we just simply copy, no? We just simply copy your J and I. And for number 2, only physical handicapped individuals can be called person with disabilities. So that will be your J. Then we apply conjunction N. Psychosocially disabled person like those with chronic illnesses cannot avail PWD ID. So that will be your negation age. No, cannot, because there is a cannot here. So that will be your negation age. If and only if, that will be your biconditional. So this will be your biconditional, as you can see. It is not true that the knowledge on the wide extent of who a PWD is has yet to be spread. So meaning to say that will be your negation J there. So this will be this how we express these symbols in words. For number 3, knowledge of the wide extent of who a PWD is has yet to be spread. If and only if. This will be your J. Your if and only if there is your biconditional. So your not here will represent your negation G, because we just simply get the negation of your proposition G there. And this will be the symbol for this statement. Your J biconditional negation G. So that's how we deal with your biconditional, dealing with your conjunction, negation, disjunction. No? With this one, we learn a lot of things for these logical operators from your negation, disjunction, negation, conditional, and biconditional. So for your activity, you can write this one in your Katleya notebook. The deadline will be announced in your group chats. You just simply put your answers in your Katleya notebook. Let A, B, and C, and D be propositions. So there's a given propositions here. In words, then you're asked to express the following logical symbols into verbal sentences. So we just simply convert this one into a verbal sentences by simply applying the concept of your logical connectors. And for an activity in 1.2, let D, E, F, and G be propositions. So again, there are given values for, or the given propositions here for your D, E, F, and G. As you can see, what will be your task? So your task now is to express the following propositions in symbols. So here there's a proposition here, there's a statement here or sentence, no? With the use of your logical connectors, we just simply express this one, following propositions in symbols. So we just simply expressing the following propositions in symbols. So thanks for watching. Please like, comment, and share, and subscribe.